Page 562, section A5, determine whether each trinomial is a perfect square. If so, factor it. If not, explain why it wasn't. So basically you're asking yourself this set of questions. First of all, to be a trinomial, it has to have 3 terms. Then to be a perfect square trinomial, you have to ask yourself, is the first term a perfect square? Is the last term a perfect square? And the most important question is, if I multiply the square roots together of those 2 previous questions and double it, do you get the middle term? So, does x squared minus 4x plus 4 have 3 terms? Yes. Is the first term a perfect square? That means, if I go to factor it, does 1, can I do the square root of 1? Yeah, I can do 1 times 1. And I can split up x squared into x and x. Is the last term a perfect square? So 4, can you do the square root of 4? Well, the square root of 4 is 2. That makes it a perfect square. So I can put a 2 here and a 2 here and say 2 times 2 is 4. Now, if you multiply x times 2, you're going to get 2x, double it. So if I double that, do I get the middle term? Is x times 2 going to give me 4x? Yes. Since I have to multiply to be a positive, the signs on the 2's have to be the same, but I have to add up to be a negative, so they both had to be negatives. So a shorter way of writing that is x minus 2 to the second power. That's what makes it a perfect square trinomial, because it's the square of a binomial when you factor it. Okay, if I go to number 3. Is 9x squared minus 12x plus 4 a trinomial? So does it have 3 terms? Yes. Is the first term a perfect square? Well, I can do the square root of 9 and get 3, so I can split 9 up into 3 and 3. I can do the square root of x squared and get x, so I can split that up into 3x and 3x. Okay, is the last term a perfect square? Yeah, 4, I can do the square root of 4 and get 2. 2 times 2 is 4. So the only way I can multiply to get a positive 4 and add up to a negative in the middle is if both of these were negatives. But if I check 3x times a negative 2 and then double that, do I get 12x? So 3x times negative 2 is negative 6x times negative 2 is... Actually, I'm going to ignore the signs. I'm just going to say it's 3x times 2. I'll worry about the signs later. Is 3x times 2 doubled going to give me 12x? And it does. So I can factor it into 3x minus 2 squared. So you can always check it. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. My insides, 3x times negative 2 is negative 6x. If I add negative 6x and negative 6x, I get negative 12x. And a negative 2 times a negative 2 is a positive 4. So this was actually my factored answer. That just proved that it did work. Okay, on number 5, does the expression have 3 terms? 1, 2, 3. Yes, it does. Is the first term a perfect square? Yes, I can split up x squared into x times x. Is the last term a perfect square? 9 square root of 9 is 3, so I can split the 9 up into a 3 and a 3. So now if I multiply these together, x times 3, double it, do I get 6x? Yes. The only way I can multiply to get a positive 9 is if my signs are the same, but if I'm going to add up to a negative, they both have to be negative. So I could shorthand this and write this x minus 3 squared. Same thing over here on number 3. I could have shorthanded it and write 3x minus 2 squared. So they all were perfect square trinomials. Number 7, a city purchased a rectangular plot of land with an area of x squared plus 24x plus 144 square yards for a park. The dimensions of the plot are of the form ax plus b, where a and b are whole numbers. Find an expression for the perimeter of the park. Find the perimeter when x equals 10. So since this is a rectangular park, the first thing I would do is I would draw a rectangle. Now what I know about that rectangle is I know the area. So I know the area is x squared plus 24x plus 144. Well, you also know that area on a rectangle is length times width. So if I could write this area as a multiplication problem, I would know my length and my width. Well, if you factor something, you get a multiplication problem. So does this fit one of our special square trinomials? So there's a 1 in front of that x squared. So it's got 3 terms, so it meets a trinomial. Can I do the square root of 1? Yes. So 1x squared is a perfect square. I can split it up in x and x. 144 is a perfect square. The square root of 144 is 12. So I can do 12 and 12. If I multiply 12 times x, I get 12x. I double it, I get 24x. It worked. So really, I don't have a rectangle. Technically, I have a square because the length and the width are the same. So I really, truly have a square where this is x plus 12 and that's x plus 12. So I figured out the length and the width by factoring the area. And the question wants to know, what's the expression for the perimeter of the park? Well, perimeter, you're going to add up all four sides. But since all four sides are the same, a quick way of adding up x plus 12 four times is just to do 4 times x plus 12. So that would give me 4x plus 48, and that would be inches. And then the last part of the question says find the perimeter when x equals 10. So then you're going to replace the x with a 10 and do 4 times 10 plus 48. And 40 plus 48 is 98, and that would be inches. Determine whether each binomial is a difference of two squares. If so, factor it. If not, explain why it's not. Well, here you've got a set of 4 questions. You have to ask, does the expression have 2 terms? Because binomial, bi means 2. Difference means subtract, so is it a subtraction problem? Is the first term a perfect square? Is the last term a perfect square? Okay, so on number 9, you have s squared minus 4 squared. So ask yourself, does the expression have 2 terms? Yes. S squared is the first term, 4 squared is the second term, so it's got 2 terms. Is it a subtraction problem? Yes, it has a subtraction sign. Is the first term a perfect square? Well, does that mean, can I split it up into the same thing? S squared splits up into s and s. So yeah. 4 squared is really 16. Can you do the square root of 16? Of course you can, because it's 4. So it was squared. 4 was squared. So you split it up into 4 and 4. But I have to multiply to get a negative 16. And the only way I can get a negative 16 is if one of the 4's is positive and the other one's negative. So it factors into s plus 4, s minus 4. So that's what a difference of 2 squares is. It's a squared minus b squared, and it always factors into a plus b times a minus b. Or you could have a minus b first and a plus b second. Okay, number 11. Does it have 2 terms? Yes. Is the first term a perfect square? Well, square root of 4 is 2. And the only way a variable to an exponent can be a perfect square is if you have an even exponent. So 4 is even, which means I can split it up, x squared and x squared. Then 9y squared. Well, I can do a square root of 9 and get 3. I can split up y squared into y and y, so I have 3y and 3y. But I want the 3's to multiply to be negative, be a negative 9. So one of them has to be positive and one of them has to be negative. So those were both perfect difference of 2 squares. Okay, what about x to the 6 minus 9? Does it have 2 terms? Yes. Is it a subtraction problem? Yes. Is the first term a perfect square? Well, the only way a variable to an exponent can be a perfect square is if the exponent's even. So I can split x to the 6th up and x to the 3rd, x to the 3rd. Is the last term a perfect square? Well, 9 is a square root. I can get 3, so I can have 3 and 3. But I got to multiply together to get a negative 9. So that means one of the 3's has to be positive, one of them has to be negative.